अच्छा ठीक है इस क्लास में ना अच्छा इस क्लास में ना we'll just focus अब एक टॉपिक वाइज है ठीक है we'll just focus on past paper topics तो different past papers and we'll just do organic revision ठीक है in this particular case so I'm just going to focus on organic chemistry questions starting with I think this is question number 3 तो उसने कहा कि in this question this question is about और ये summer 16 है 1 second so remember just organic chemistry past paper questions तो वो latest वाले करेंगे let's start with this one for now so this is about crude oil crude oil kind of is saying that so this is fractional distillation what has to be done to the crude oil before it enters the column fractionating column so you have to evaporate it you have to vaporize it at high temperatures ठीक है that is what is so it's vaporized at high temperatures अच्छा what trend in structure is there from A to F is there from fraction A to F in structure is there from A to F so what is the trend from A to F in the structure of a molecule what happens to the molecule of the organic compound does it become bigger or smaller bottom के ऊपर you get big molecules ठीक है you get big molecules and big molecules have higher melting and boiling points so bigger molecules at the bottom yeah A to F the size of molecule increases ठीक है but to be precise that was all he wanted in this particular case so then he says state the trends in the two properties of the fractions from A to F so when the size of the molecule increases A to F again so since the size of the molecule increases the melting and boiling points increase और क्या होता है viscosity increases there's another one as the molecule size becomes bigger the flammability also decreases as then he says the naphtha fraction from fractional distillation of crude oil is used as a starting material for cracking write an equation for the cracking of C12H26 to form products ethene and one other hydrocarbon in a 2:1 mole ratio. So one other hydrocarbon in a 2:1 mole ratio. So you're cracking C12H26. So it should crack to form ethene, which is C2H4. So there has to be another product as well. So 2 ratio. He said that it should be in 2:1 mole ratio. So if this is 2, so that's 4 carbon atoms. So piche kitne bach gaye? Out of 4, 12 out of 4, that's you're left with 8. So this other hydrocarbon is going to have 8 carbon atoms. And how many hydrogen atoms would it have? Okay, I've got 26 minus 8, that's 18, I think. So that's it.
Sir, what if we made H2 gas?
You can do that. Okay, in that case, he said no H2 gas, one other hydrocarbon, that's it. So no H2 gas. Was it clearly mentioned, kids? Just one other hydrocarbon. Clear? So there's no H2 gas, okay? That's the next part. Suggest a use for each of the products from your equations. Explain what makes each product suitable for this use. So use of ethene. Where is ethene used in?
Sir, alcohol making.
हाँ चलो you can say that लेकिन इतना that's not that important.
How about the formation of polyethene, sir?
Polyethene, that's one big major use. So I mean, polyethylene is your normal everyday plastic, right? Shopping bags, etc. So polyethylene. Lekin, what else? So what is the question? Explain what makes each product from one suitable for the use you suggest. State a use for each of the products from your equation in one. This one. So, or explanation, use of the other product. What's the use of this other product? What is this thing? ये कहाँ पे use होता है?
High octane.
ठीक है, high octane fuels. So that's उसकी explanation. It's used to produce energy. Obviously, ठीक है. So that one is used to produce energy. So high octane fuels. That's the other one. Okay,
Sir,
next
what's
part.
Sir, what's the explanation for ethene, sir? Use of ethene.
कि पॉलीथीन, हाँ उसके अंदर explanation, ठीक है, हम उसको आंसर कर लेते हैं. Probably suggest the use for each of the products. Explain what makes each product suitable for the use. How can you make polyethylene from ethene? Because it's got a double bond. It's an unsaturated hydrocarbon which can be polymerized. You can make polymers out of it. So it can undergo addition. Polymerization. ठीक है, मैंने question को सही interpret किया ना कि explain what makes each product suitable for the use you suggest. ठीक है, so why is ethene suitable for making polyethylene? That's the reason for that. ठीक है, is this clear?
Yes, sir.
Yes.
अच्छा, तो दूसरा octane का क्या होगा? It's high octane fuel, right? So why is octane suitable for a fuel? Basically, it produces a lot of energy. That's
More flammable.
ठीक है, produces more energy per gram and more flammable as well. Next one. Burning hydrocarbons can cause a number of environmental problems. The products of internal combustion engines can include your oxides of nitrogen and oxides of carbon. Sulfur dioxide is a byproduct of burning coal. Explain how and why oxides of nitrogen are produced in internal combustion engines. So why are oxides produced? Because the N2, air has N2 and O2, and they react together. Okay, you can write an equation. Okay, this is air that contains N2 and O2, and the engine provides the actuation energy. The high temperature in the engine, it provides it ends up providing the actuation energy. Write an equation for the reaction between nitrogen monoxide and carbon monoxide in a catalytic converter. So what happens in a catalytic converter? The harmful oxides, nitrogen monoxide, and the other one is carbon monoxide, they would react together, and N2 will be produced and carbon dioxide gets produced, and you can balance this equation accordingly. So it's going to be 2NO or C को balance करना. How would this get balanced? Okay, the 3 oxygens on this side.
Yeah, so you can just put 2 in CO and 2 in CO2.
No, are the oxygens now balanced? They are balanced. Okay, that's fine. Write an equation to show the involvement of nitrogen monoxide in the formation of acid rain from sulfur. Write an equation to show the involvement of nitrogen monoxide. So how is acid rain formed? The first step is that the sulfur dioxide reacts with NO2, Balki your starting point is NO. So the NO first gets oxidized in the atmosphere and turns into NO2. And then that NO2 oxidizes the SO2 and forms SO3. And then that SO3 goes and reacts with water and turns into sulfuric acid. All of this is in the notes. The formation of acid rain. Two problems associated with acid rain. What are the two problems?
So it damages limestone structures and metal structures and increases the acidity of the lakes and soils.
So acidic lakes and soils, you're going to get that. As the next one is still organic. So remember, we're just focusing on organic questions now. So there are two molecules. Give the systematic name of acetoin, whatever that is. What is the name of this molecule? Okay, what would you call this?
Say 3-hydroxybutone.
3-hydroxy. So there are 4 carbon atoms and it's a ketone. So ketone has the higher precedence. So it is butone. And the other part is there's an OH group on the third one. It's 3-hydroxybutone, butane-2-one, sorry. ANB, that's butane-2-one. Next part is identify the reagents and conditions necessary for the conversion of this thing into acetoin to a diacetyl. So how do you turn an alcohol to a ketone? The alcohol turns into a...
Sir, we could use hot concentrated KMNO4 or potassium dichromate.
Not hot concentrated KMNO4.
Not hot?
I
Yeah,
mean,
like
just KMNO4. KMNO4, acidified and reflux.
Okay.
Because hot concentrated KMNO4 is for alkenes. I mean, it is KMNO4. KMNO4 is fine. The hot concentrated part is for oxidation of alkenes. So that's not used. It's a simple alcohol, a secondary alcohol. So what does a secondary alcohol turn into? It turns into a ketone. You just need KMNO4 acidified and you need reflux with that. So we're just going to add that. So the reagent is going to be KMNO4. The conditions would be acidified and reflux. And also when you're answering the question, make sure you know what each one of these things, what do they mean? If he's asking for reagents, just write the reagent. If he's asking for conditions, then write the conditions. Both. So I said this one infrared spectrum of acetoin is shown. Acetoin is this thing. It's a ketone and it's an alcohol as well. So you can clearly see. I mean, you don't even need to. You should remember this. Anything that at 1600, that's around 1600, 1700. That's a serial bond O. Anything that's above 3000 in the 3200 to 3600 range, that's an OH bond that's absorbing the infrared spectrum. So explain the main features of this spectrum with reference to the peaks with wave numbers greater than 1500. 1500 say niche, below that there's a lot of confusion, so you don't really comment on that. So I guess that's it. Just two peaks. You always get a peak at 3000, which is due to CH. Every molecule almost has this peak because every molecule has CH bonds, and they would also be absorbing infrared spectrum frequencies around 3000 mark. Okay. I said, like in paper, what you're not going to give them estimates. You're going to give them exact values. The table will be given to you. So tell them the exact values at which. So serial bond O, that's 1640 to 1750. Okay, so that's the range in which you're going to get serial bond O. OH is 3200 to 3650. Anything that's within that range, that's an OH. Or CH kahan pe? That's 2850 to 3100. So that's your OH. So CH. I said next one. State explain how the infrared spectrum for diacetyl would differ from infrared spectrum for acetone. So the only difference between them would be that there's not going to be no OH. There's not going to be any OH over here. So there's not going to be an absorption at the 3200, 3650 in this range. That will not be there. So the difference will be the serial bond would still be there. Lekin ye wali jo peak hai na, this one, this will be absent. It's not going to be there.
Sir,
Yeah.
sir, can you also say that the peak for the C double bond O will become like from the top, it will become like even like in terms of width, it will become even larger? Can you say that?
Hey, it's already serial bond is already stronger. So I mean, that would not be that noticeable. The serial bond already has a strong absorption. I said next one is a sample of acetone is reacted with concentrated sulfuric acid. A single product is formed that does not exhibit stereoisomerism. However, if a sample of acetone is reacted with HBr, a mixture of pair of stereoisomers is produced. Give the structural formula of the product of the reaction of acetone with concentrated sulfuric acid. So acetone with kya hoga? What's going to happen? Acetone with concentrated sulfuric acid. But this is dehydration. It's I mean, this is acetone. It's OH on the, and these are all your H atoms. So the OH is going to be lost, and an H is going to be lost from the neighboring carbon atom, and it will form a double bond. Okay, a concentrated sulfuric acid is going to dehydrate. Ye yahan pe concentrated sulfuric acid is, it turns an alcohol back into an alkene. So kya pucha? Naam pucha? What's the name for this? Is he asking for the name or? No, just the structural formula. So you can write this formula, or you can write the condensed version, which is, what is the condensed version? It's CH3, CO, and then you have CH, and double bond, and then CH2. And it is not showing stereoisomerism as well, because around the double bond, both of them are H atoms. So you won't get stereoisomers in this case. As the next part, explain why the product does not exhibit stereoisomerism. So you had a double bond. So the carbon double bond carbon, the carbon atom is bonded to two H atoms. So carbon in serial bond C is bonded to two H atoms, which means K. So no geometric isomers. Explain why the product of reaction of acetone with HBr does not exhibit stereoisomerism. So now the same molecule, acetine, isko main wapas kar deta hu, theek hai, that's bring the OH back. So what's going to happen with HBr? These are all your H atoms. What's going to happen with HBr?
Yeah, I think they have optical isomerism.
It will replace the OH.
No, pehli cheez. HBr will replace the OH. That's the first, because he's talking about the reaction of this thing. This is showing stereoisomers. The acetine molecule is optical. You've got a chiral carbon atom in the center. But now he's talking about the reaction with HBr. Okay, so what's going to happen with the HBr that the OH will get substituted by even a reaction. It's this one. That whenever you have an alcohol, the alcohol, if you react it with HBr plus heat, etc., it will turn into a halogenoalkane. So it's going to turn, you're going to have a Br over here. Does it still show optical isomers? Will it show optical isomers?
Yes, sir.
I mean, it will, right? So what did he say over there? Actually, he says does. I thought it does not. So it will show, so you're going to tell them that it's got a chiral carbon atom, which is basically a carbon that's bonded to 4 different groups. And it's bonded to 4 different groups. And I guess that's about it. You can also add that it's in, there's no plane or line of symmetry around this carbon atom, which is why the mirrored version is actually going to be a different molecule. But no plane of symmetry ki bajaye, you just write asymmetric carbon. That one is in asymmetric carbon atom. Up here, he's asking you to draw the conventional way of the 2 stereoisomers. I'll just do it over here. Okay. What's the what do you call it there? So what did I have? I had an H and a Br and a CH3 on one side. And on the other side, I had a double bond O. And then I had a CH3 as well. So the mirrored version would be exactly the same, but reflected, laterally inverted left to right. So the dotted line would be on that side. And my Br bond would be this side. So that's your 2 mirrored versions. Mr. Let's do another one, just organic questions. So moles can forget that. Achha, just organic, this one. This is another paper, summer 16 question, paper 2.2. So this one is, the questions about molecules with molecular formula C4H8O2. Give the structural formula of the pair of chain isomers with the formula C4H8O2 that are carboxylic acids. Chain isomers, so you have to play around with the carbon chain isomers. Both of them are carboxylic acids. So one of them could be, the 4 carbon atoms could be in a straight line and it's a carboxylic acid. Or baki wo H likh do saath, theek hai. So these are your H atoms. The other one would be that instead of 4, kya hoga, you'll have 3 carbon atoms and there's going to be 1 branch. और ये उसके साथ आप H add कर दो. ठीक है, so you have these 2 carboxylic acids. Here the next one is give the structural formula of a pair of positional isomers with the formula C4H8O2. Position where you can only change the position, that are esters. So what is an ester? Ester is a serial bond O in the middle of the chain. So I've got 4 carbon atoms. What I can do is I can have 1 carbon atom over here and I can have 3 carbon atoms on the other side. So 3 carbon atoms, 2 hydrogens, 3 hydrogens over here. तो ये क्या बना? This is one isomer, ठीक है, where it's an ester, ठीक है. Now the only thing I can do is I can change the position of the ester group. So what I can do is I can have it slightly to the left, and I can have 2 carbon atoms on the other side. So I can have 2 of them up the other side. अच्छा, अब ये कि so these are your positional isomers with the formula C4H8 O2. And I can make more of them actually. I can make a third one as well. I can put the cedral bond further to the left. So that will give me another ester. And I can have 3 carbon atoms on the other side. ये सारे H है. So give the reagents and conditions needed to produce one of your esters in ester formation के लिए what is required? What is the reagent required? I mean, let's say I want to produce, let's say
concentrated F2SO4.
वो तो conditions हो गई ना, reagents. Let's say मैंने ये produce करना है, this one. So what would be required? I would require an alcohol, which is methanol. The right side is going to be methanol, that's 1 carbon atom, and the left side would be 3 carbon atoms, that's a propanoic acid molecule. So these are my reagents. Up conditions, what you need is you need concentrated sulfuric acid, which is a catalyst in this case, and reflux. Clear?
Yes, sir.
अच्छा, अगला part. अच्छा, अगला part ये कि infrared spectrum again. Again 1600. You see a 1600. That's clearly a cedral bond O. I say meaningless. So this is again 3000. I told you that you're going to get something at 3000. That's your CH. So you got a cedral bond O. So infrared spectra of one of the esters and of another isomer X are shown. X decolorizes bromine water and is not an ester or an acid. So X over here, this is infrared spectrum of the ester. So you got an ester. Ester में क्या होता है? Cedral bond O and O, that it always has this thing. It always has cedral bond O and so you always have a CO bond as well. So you can actually see that CO bond as well. CO bond कहाँ पे होता है? CO bond is over here. What is the range? That's 1040 to 1300. You got a strong, sharp absorption. So an ester also has this thing. तो अगर इसको देखो ना जाके CO, that's around 1300. So this one is probably going to be CO as well. So anyways, you can't really tell which ester this is. It could be any ester in this case. As the next part, infrared spectrum of X, so strong and wide absorption around the 3000. So when do you get a strong and wide absorption, strong and broad absorption? So that must be an OH that belongs to the carboxylic acid. So ye wala jo hai, this is this over here is an OH that belongs to a it belongs to a carboxylic acid, definitely. Doesn't really have a lot happening over here. Below 1500, you can't really tell much. There's hardly, I mean, no real absorption at the 1600, at least not a strong one. So we can safely say that it does not have cedral bond O. Explain the differences between these two spectra with particular reference to the peaks with wave numbers above 1500. उसने above 1500 का हुआ है. So मतलब मांगा कि explain the differences between the two spectra. तो एक difference तो ये होगा कि you have so one difference is this one has a serial bond O. The other one does not have a serial bond O. That's one major difference. ठीक है, that's one major difference. और क्या हो सकता है?
One which is for carboxylic acid and one is for ester.
The first one does not have OH. ठीक है, this one does not have OH because there's no absorption above the 3200. There's no strong and broad absorption. So it's got no OH. ठीक है, this one has no OH. So
Sir,
yeah.
does X have a C double bond C, because it said it decolorizes bromine water?
So it's got serial bond C. So it's got a serial bond C. Where does the serial bond C show up? Serial bond C barely shows up. TK, it's very hard to actually detect can we see a serial bond C? Need actually, you have an alkenes, it's weak, 1500 to 1680. So based on the table over here, तो ये मैं उससे पता लगा कि not from the table, you got a weak absorption around there. So this one over here must be the serial bond C, because we already knew that it's a serial bond C because he talked about the bromine water thing. So we can say that it's got a serial bond C as well, right? और तो ठीक है, इसके ऊपर मुझे डाउट है कि this is an OH that is not carboxylic acid. Reason it's not carboxylic acid is because the OH that belongs to a carboxylic acid, its range is 2500 to 3000. Above 3000, it's usually an alcohol. So if you look carefully about this one, this is clearly above 3000. So this is just an OH, not a carboxylic acid OH.
Yes, so they also stated that it's neither an ester or an acid.
Because if we doubt, like if OH is from, if you're saying that OH is from carboxylic acid, they clearly stated that it's not a carboxylic acid TK in the question. So I guess that's it. So you're just going to write, you're going to quote the values, TK, quote the values from the table. This is serial bond O, this has no serial bond O. This has got a serial double bond C, plus this one has an OH from an alcohol. That has no OH at all. TK, there's no OH over here. So 3 marks, I think, and you'll get those marks. So next part. Okay, you've got this question, which is identify the suitable reagents for reactions 1 and 2. So what is happening in reaction number 1? What's a primary alcohol turning into a carboxylic acid? So
Oxidation.
Okay, that's oxidation. Kya reagents and that's
Acidified KMnO4.
Okay, KMnO4, K2Cr2O7, acidified and reflux. What about reaction number 2? What's happening over there?
Heat under distillation.
Okay, so instead of
Distillation.
reflux, it's going to be, everything would be exactly the same. Acidified, but heat with distillation. The reason being that you don't want the primary alcohol to go further, get further oxidized to carboxylic acids. You want to stop over here. So if you want to stop over here, you have to distill. You have to take out the aldehyde as quickly as it is formed. Aldehydes have lower melting and boiling points compared to alcohols and carboxylic acids, so they will evaporate and they'll leave the mixture. Instead, explain how the reaction should be carried out to ensure that the reaction over here, they just ask for the reagent for both reactions 1 and 2. So dono ke cases where the reagents were what? K2Cr2O7 or acidified K2Cr2O7. But यहाँ पे state explain how the reaction should be carried out to ensure that the reaction 2 rather than 1 occurs. So वहाँ पे you would mention that you would heat under distillation. So यहाँ पे you instead of reflux. So identify the necessary reagents and conditions for each of the reactions 3 and 4. 3 में क्या हो रहा है? Alcohol turning into an alkene. What is that?
Dehydration.
ठीक है, वो ये it's Al2O3 plus heat. ठीक है, that's an alcohol turning into an alkene, so that's Al2O3 plus heat. या फिर concentrated H2SO4 plus heat. Or 4 here, what's 4? OH substituted by a Br.
Nucleophilic substitution, sir.
नहीं, लेकिन reagents.
HBr. Or reagents.
Yeah, so
HBr
these,
plus heat.
so that's HBr plus heat or इस वाले के there are many reagents, ठीक है, for this one. Okay, you could use red phosphorus plus bromine plus heat or PBr3 plus heat as well. So the alcohol will turn into a halogenoalkane. So what else? You've got this reaction. This is aldehyde ketones का क्या reaction होता है mechanism? That's nucleophilic. That's nucleophilic addition. ठीक है, that's this one. Okay, they always undergo nucleophilic addition, which is this. Okay, the carbonyl group is polar. The carbon is positive. The Cn-1 is going to get attracted to it. The electrons are going to get repelled. So the top oxygen -1 that will then bond with H. So you're just going to copy that mechanism. You're going to draw every single TK 4 marks. Remember your mechanisms by heart. There's a carbon positive. The Cn, it's the C that has the lone pairs. The lone pairs are going to get attracted to the carbon, and the electrons in the double bond are going to get repelled. Then what happens is that the CH3CH2 तो एक साइड से क्या हुआ है, the CN has attached and the C has attached, not the N. Next step, it's the H+1 from HCN that's going to get attracted to the lone pairs, and that part will become OH. Okay, so the carbon will have a CN and it will also have an OH. So ये आपका mechanism है, ठीक है? So make sure every single thing about this mechanism is correct. अच्छा, फिर वही है कि draw the two stereoisomers. It's a chiral molecule. तो बस इसको we draw कर लो. So you got an OH, you got a CN, you've got an H, and you've got CH3CH2. Or it's got a reflected version, okay, that's going to be OH again. Dotted is going to be this way, H slightly this way. CH2, CH3 on the other side. As I suggest, why a mixture of two isomers is formed by reaction number 5. Okay, why are two isomers formed in reaction number 5? Why? What reason? Okay, why are you getting two isomers?
This is just a chiral center again, is it, sir?
It is a chiral center, but why are you not getting only this? Why are you getting the other one as well?
For the reflected version.
नहीं वो तो ठीक है, but the question is कि why is this happening? Why are you getting two of them?
There's
You
no
have
double
a
bond. No double bond.
उससे क्या होगा? Double bond नहीं है. अच्छा, this one slightly you have to visualize this in 3 dimensions. It's slightly harder to visualize. But tell me, what's the shape of this molecule? ये जो carbon over here, the first one. What is the shape of this molecule when it's forming a double bond?
Trigonal planar.
ठीक है, that's trigonal planar. ठीक है, तो उधर से start करते हैं. Let's focus on the shape. Double bond O, and दो साइडों पे ना there was a CH3 CH2, and on one side it was in H. So imagine this as a fan-shaped molecule. So it's completely planar, it's completely flat, and the angles are going to be 120 degrees. The carbon in the middle is the one that's positive, right? And the oxygen over here is the negative one. I'm going to draw another one. मैं वो explain करूँ कि why are you getting two isomers, ठीक है? मतलब although two are possible, but why are you getting two? Why not just one of them? So let me draw another one, ठीक है? The same one. CH3CH2 था. I got a C double bond O, and I've got an H. ठीक है? Again, the thing is that the middle one is actually slightly positive. Achha, now imagine कि fan की तरह ना, the molecule looks like a fan, ठीक है? It's completely fan-like. So where will the Cn-1 come from? The Cn-1 can attack from the top, right? So fan की ना दो sides हैं. There's a top side and there's a bottom side. Or what could happen is that the Cn-1 could attack from the bottom as well. So do you get the point that the Cn-1, you have a fan and the Cn-1 could attach from the top, or the Cn-1 could attach from the bottom side as well. तो अगर वो bottom side से attach होता है, let's say वो top से attach होता है, so all the other bonds, what's going to happen to all the other bonds? All the other bonds are going to be pushed downwards, right? Because of repulsion. क्योंकि negative आ रहा है ना, तो all the bonds are going to be pushed downwards. So your molecule is going to have kind of this shape, that the carbon and all the bonds that it had are going to be pushed downwards. Okay, so the CH2, CH3 will be pushed downwards. The H will be pushed downwards as well. Oxygen ka to pura electron cloudy sara, it's going to shift and it's going to become O-1. While the Cn-1 gets attached from the top. So is this clear? This one, you clear?
Yes, sir.
So yahan pe, what's going to happen over here now? Now over here in this other one, the Cn-1 is attacking from the bottom side of the fan. The fan had two sides. So if it attacks or attaches from the bottom side, so all the other bonds, what's going to happen to the other bonds? They're going to be pushed upwards, right? So they all will be pushed in the upward direction. The oxygen gets pushed upwards. The H also gets pushed upwards. The CH2, CH3. All of the bonds, they get pushed upwards, or O-1 ban jayega. And the Cn will come and get itself attached at the bottom. So both of them are basically mirrored versions of each other. Okay? So they're both mirrored versions of each other. So the reason you're getting both mirrored version is that the Cn-1 had an option. It had an option to either attack from the top side, or it had an option to attack from the bottom side. In either case, you'll get two opposite optical isomers. Is that clear?
So is there right side and left side as well?
किस पे इसमें? नहीं, open side कौन सी है? Top है और bottom है ना?
Oh, okay.
I mean, the top and bottom side are completely open, so it's going to prefer the top side or the bottom side. Okay, so the point is, like if you didn't have this option, you would only get one enantiomer, not the other one. But you've got both options, and both of them have equal probability. So यहाँ पे ना, you're going to get a mixture of both enantiomers. You're going to get both of them. So यहाँ पे explanation के अंदर what you're going to write is, as remember, whenever the intermediate or whenever the molecule is planar, so or optical isomers ban rahe, so there's an equal probability of getting both optical isomers, because your whatever is attacking that could attack, has two choices. It could either attack from the top or it could attack from the bottom side. So उसके अंदर लिखते हैं कि जो molecule है, this is a planar molecule. It's trigonal planar. Molecule था कौन सा? It was I mean, whatever this thing is, it's I think it's propanone. So you're gonna write that propanone. Propanol, sorry. It is propanol, right? So propanol is trigonal planar. And the Cn-1 can attack from either side. I say question बहुत rare है. It's a very small question. It's usually just a 2-mark question, but it doesn't really, they don't really ask that frequently. But keep this thing in mind. So just say yeah, na, let me explain, give you another mechanism. ठीक है? For example, if you look at a halogenoalkane reaction, अच्छा यहाँ पे भी ना इधर भी देखो कि let's say you have a carbocation, right? A carbocation has 3 bonds. 3 bonds makes it trigonal planar. So if the Br-1, think of this in 3 dimensions. If the Br-1 is attacking, it could either attack the carbon from the top or it could attack it from the bottom. So यहाँ पे भी ना the stereochemistry is possible. You're going to get both types of, because the intermediate on which the Br- was attacking, it's either banega to nahi because it's not meeting the conditions. But if it were meeting the conditions, you'll get both types of optical isomers. Clear है ये?
Yes, sir.
और एक मैं आइडिया देता हूँ nucleophilic substitution का. Now, nucleophilic substitution, the OH-1 attacks and the Cl gets knocked out, right? So if the Cl is over here, so this is a negative Cl. The OH will always be attacking from the opposite side of that Cl. So it's always attacking from just one side, which is why जो भी molecule बनेगा, it's always going to be the same molecule. क्योंकि यहाँ पे it doesn't have an option to attack from any side it prefers. यहाँ पे the Cl is negative. So the negative nucleophile in nucleophilic substitution is always going to come from the other side. So which is why it's always attacking from just one side, which is why it's always bonded to the same, but a 3-dimensional space when it's always bonded to the same side. So this, or even if it's capable of forming stereoisomers, it won't form stereoisomers. क्योंकि वो mechanism ऐसा है, ठीक है? Is this part clear? This one?
Yes, sir.
So let's ये पता नहीं किया हुआ है कि नहीं किया हुआ. अच्छा, again organic. इस question में, ठीक है, you got a question of organic. ये हमने किया था, एक सेकेंड. So let's say this one. I said, what is meant by the term hydrocarbon? So it's what? Molecule containing carbon and hydrogen only. Name the raw material that is used to crude oil. ठीक है, all of this is produced from petroleum or crude oil. As a compound V is found in naphtha, it has a molecular formula C10H22. When V is heated at a high pressure in the absence of an equal number of moles of ethene, propene, and W are made. W is made of a compound which is straight chain, and it's is compound made of straight chain saturated molecules. Name the process. So what is the process called? Okay, V is heated at high pressures. What's the process called?
Cracking, sir.
Okay, this one is cracking. And W ka structure, you have to figure out the structure of W. So you got C10H22. So it's being cracked. What's happening? Okay, number of moles of ethene. So ethene is formed. Propene is formed. So that's C3. Propene kya hota hai? That's C3H8. And W. So what's W? I think you're just left with 5 more. कितना होगा 5?
H10.
अच्छा नहीं, H12 होगा क्योंकि ये जो था ना, this is propane. This is, I have to make that a propene. Okay, this one is propene. Propene is separated from the mixture and heated in air in the presence of a catalyst. Propene is oxidized to X, which contains two functional groups. As a propene is separated from mixture and heated in air in the presence of a catalyst. Effervescence is seen when Na2CO3 is added. So, कौन सा compound होगा in X? Like, who's going to?
Carboxylic acid. Sir.
Okay, that's going to be carboxylic acid. Identify the functional group present in X. That's done. Identify a reagent which would be used to show that X contains a double bond. So, how do you identify a double bond?
Add bromine water, it turns colorless.
Okay, तो बस इसका bromine water and that is decolorized. Or yeah, red brown too. Or orange to colorless. Then he says that X reacts with another reagent to form Y. So molecules of Y react to form addition polymers. The diagram shows the repeat unit of a polymer. Draw the structure of the monomer. The monomer is easy. So all you have to do is, these are your two carbon atoms, get rid of the continuation bonds and put a double bond in between back. Okay? So it's two carbon atoms that have a double bond. And one of them has this top pinna, it's got a double bond O and O minus 1, Na+1. And you can add the H's as well. I say whenever they say okay, draw the structural formula, that's the most general term. Structural formula is any formula that tells you the structure of the molecule. Okay? So you could come up with a condensed version of this as well. Either in a displayed draw, this is a fully displayed, that's also a structural formula. I could have drawn a condensed version, which is CH2, then a double bond, then CH, and then I had what COO minus 1 and Na+1. I could have written it like this, or I could have drawn a skeletal formula as well. I could have drawn this thing that it had a double bond O minus 1. All of them are structural formulas. जब वो specific होता है ना, just draw the skeletal formula or just draw the fully displayed formula, then you have to be specific. Like when he's structural formula is the most general term of drawing or writing the answer. Just any formula that gives you the structure. As a polymer Z is useful because it absorbs large amounts of water. तो बताओ why Z कौन सा आ गया? Z तो where's Z? As this is polymer Z. Why does it absorb large amounts of water? What's the reason for this? Why would anything absorb water? What is necessary for absorption of water in terms of intermolecular forces? क्या चाहिए उसके लिए? वैशा क्या होगा for absorbing water? You would need to form hydrogen bonds. Okay, which it is capable of. The O minus 1 is going to get attracted to the. So identify. So he didn't ask for that anyways, but combustion, he says polymer Z is useful because it absorbs large amounts of water. However, there are problems associated with the disposal of products containing polymer Z. Combustion is not an appropriate method to dispose of pure Z because the process releases harmful gases. Some of these gases contribute to the enhanced greenhouse gas. Identify gas released during the combustion of Z which contributes to the enhanced greenhouse gas. So greenhouse gas कौन सी? It's carbon dioxide, right? Or remember हमने पहले discuss किया था? The word enhanced. You have greenhouse gas, greenhouse effect that is natural. Enhanced is due to human activity. The extra carbon dioxide that gets produced, the extra chlorofluorocarbons that get produced. Identify another gas which could be produced during the combustion of pure Z. Describe a consequence other than the enhanced greenhouse effect of its release. So carbon, so you're going to get carbon monoxide, which causes choking, etc. So that could be the possible other gas. ठीक है, there's probably no other gas. Iski combustions are, these are the only two gases that are going to be produced. The other one is water, which is obviously not a gas at room temperature. चलो ठीक है, यहीं पे छोड़ें, कल कंटिन्यू करते हैं. कोई क्वेश्चंस नहीं है किसी के पास?
No, sir.
So when there's
Haan
a question like when they ask for a dots and cross diagram, then they have to draw the outer shell. So is that something we can do freehand, sir? Or is that something that requires the use of a compass?
नहीं, freehand obviously.
Oh, freehand. Okay.
हाँ. जैसे यहाँ पे, although they gave you the circles over here, ठीक है, so I mean, if you want to draw the dot and cross over here, that's carbon and oxygen form a double bond, right? This is single bond. This will be single bond, and oxygen has 6 electrons, so there are 4 electrons that are left, and this oxygen also has 4 electrons left. ठीक है, so that's your dot and cross. चलिए ठीक है, कल कंटिन्यू करते हैं. ठीक है,
Just
ओके, अल्लाह हाफिज़.
happens.
Office.